Hello students. So today is the lecture number 4 of design and analysis of algorithm. In today's lecture we will discuss step frequency count table with few examples. First of all, let me tell you what is step frequency count table. Step frequency count table or step frequency count method is one of the method to analyze the time complexity of an algorithm. In this method, we count the number of times each instruction is executed. One of the basis of such count, we calculate the time complexity with the help of such count, right? So it is one of the method to analyze the complexity. In lecture number 3, I have explained you the process of analyzing complexity, analyzing time complexity with the help of constant, then loops, nested loops, sequential, conditional and logarithm with some basic examples. This is the another method of analyzing a time complexity. So by the time you will be in such a position where you will get your expertise, you will develop your expertise uh, as far as analyzing time complexity is concerned, then it would be your choice which method you want to adopt for analyzing time complexity, right? So let's discuss with some example. For example, here we have to design an algorithm to find the largest element of an array of size n equal to 10 first, then n equal to 100, then n, and analyze it through SFC table and raw analysis table at the end. This is the problem we have to address. So now first of all, we have to design an algorithm for a given problem. So to design an algorithm for the largest element of an array of size n equal to 10, what should be the formal description of algorithm? Obviously, name of an algorithm, right? Number 2, an array of integer. Number 3, preconditions or a state of a machine means the state of a machine prior to execution of algorithm, right? For example, we need to declare an array of size n equal to 10, obviously. Then point number 4, we would require state of execution of algorithm means after execution we have to find out what is the maximum or largest element of an array, and finally body of an algorithm. So here is the formal description of an algorithm, right? So now we have to design an algorithm. How can we design an algorithm of a simple problem? Now students, here is the algorithm. I will explain the SFC table later on. Right now you just focus on the algorithm. Start algorithm max. Here is the name of algorithm, right? It's an initialization. Okay, we have initialized max. For I, here we have used I for loop. 2 to 9 means that this loop is not for printing a value. The noticeable thing is why this loop is running from 2 to 9, because it is not for printing a value, it is for comparison purpose. So when we have 10 values, so obviously we would require how many comparisons? 9 comparisons. There would be a comparison from 1 to 2. It will compare value 1 with value 2. So there would be a second comparison from value 2 to value 3. There would be a third comparison from value 3 to value 4 and so on. So obviously 2 means that it will start comparison of value 1 with 2. So it will compare the value 2 to 9 means n minus 1 values. I hope you got my point, right? Here is the comparison process. Just look at the mouse. For better understanding, listen my lecture and focus on the mouse. So you get to know which line I am explaining, okay? So if A into I means if the array of A is greater than max, means it will compare the whole array, right? It will compare the whole array. So we have to find whatever element would be the greatest element. We have to find that element in this keyword, which is called max. We have used if statement, and if. We have used a for loop, and for, and out max is the variable in which we will print the maximum value or the greatest value, right? So here is a simple algorithm for finding the largest element, right? So here is the algorithm. Now I move on to the SFC table. As I explained before, SFC table is a method of analyzing time complexity. So here this column is used for steps, means which line will take how many computational steps. If the frequency means the best case is the minimum and the worst case is the maximum, and count stands for C, frequency stands for F, steps stands for S, right? Frequency means the best. Frequency, we can divide frequency in two further columns, minimum and maximum. Minimum means how many lines it will take in best case, how many lines it will take in worst case. Count, C is equal to S into F, right? C is equal to S into F means count stands for steps multiply frequency. Minimum stands for best and maximum stands for worst, right? So let's move on. Now in this step we have initialized a variable. So I have used two identifier, A and max. So obviously it will take 2 steps, right? In this step I have again used two identifier. One is max and I will call A into I combined with the second identifier. So A into I is greater than max. It is also will also take 2 steps, right? Now A into I, after finding the greatest element, whatever the element would be, I will assign in max. So here is one variable and the second variable. I will take this A into I as a one variable and max is the second variable. So two variables, 2 steps. Out max, one variable, 1. I repeat, starting from beginning. Here is the A into 1. I have initialized. Now two variables, 2 steps. Here max is the first identifier and A into I am taking it as a one identifier combinedly, right? 2 steps. A into I and max. I am taking A into I as a one as a single identifier and max would be the second identifier. So I will take it as a 2 steps, right? it will take 2 steps. Outmax, it will take only 1 step to print whatever the largest element, right? Now, here 2 steps. Now, frequency is the minimum frequency. It will take minimum 1 step and maximum 1 step, right? 2 variables, I am just initializing a variable. So, it will take minimum 1 steps, means it will take the frequency, means the how many times the repetition. So, the best case, the best frequency would be 1 and the worst frequency would also be 1, right? So, 2 multiplied by 1 count is S into F, means in count we have to multiply this with this, right? So, 2 multiplied by 1 we will get 2 in minimum, and again 2 multiplied by 1 I will again get 2 in maximum, right? Now move on to, now for is not an executable part, so we will just omit 4 and move on to the executional part. So here if a into I is greater than max, then it's an executional part, right? So how many times it will compare values? It will compare value minimum 9 times and maximum 9 times. Why? Because whenever we compare the values, whenever we find the complexity of an algorithm, we are always interested in the worst case, right? So it will take minimum 9 steps and maximum also 9 steps. 2 multiplied by 9, 18, and 2 multiplied by 9 again 18, right? Okay, it will take 9 steps in minimum and 9 steps in maximum. So 2 multiplied by 9, 18, 2 multiplied by 9 maximum 18. Got it? Now, after comparing all the values, now I just have to assign. Now I have compared, so it will now in this step, I can in this step, if it will find the value at, it will assign the value in the minimum steps, I will take it as a 0, and in maximum steps obviously it will take 9 steps. Now here I can write 0 in the best case and 9 in the worst case, right? Because we have already done the comparison, now it is just the assignment process. So here I can use 0 for minimum and 9 for maximum, but we cannot use 0 here because in this step we are always interested in the worst case. Comparison is done in this step. Comparison is not done in this step. In this step, I am just assigning the greatest value to the variable called max, right? So here 2 multiplied by 9, 2 multiplied by 0, sorry, is the 0, and 2 multiplied by 9 is the 18. Got it? Now, outmax 1, minimum 1, maximum 1, 1 multiplied by 1, we will get 1, 1 multiplied by 1, we will get 1, right? I hope you have understood the analysis. Now, I'll just add the count, I'll just count the steps. So 18 plus 2, 20 plus 1, 21, 2 plus 18 plus 18 plus 1 is the 9, which means for finding the largest element of an array of size n equal to 10 will take 21 steps in minimum and 39 steps in maximum, right? Now let's do the same problem for n equal to 100. Here is the same problem for n equal to 100. In this, I have used the same variable, right? The loop will run from 2 to 99. To identifier, number one, I will take it as a single identifier. This one is the second identifier. So to identifier, 2 steps, minimum 1, maximum 1, 2 multiplied by 1, 2 multiplied by 1, 2, 2 multiplied by 1, 2, right? Because C is equal to S into F. S stand for step and frequency stand for F, right? So the same process, this time loop will run from 2 to 99. Again the same process, maximum is the identifier number 1, A into I the identifier number 2, right? Okay. Now again it will take 99 steps in minimum rather than 9. It will take 99 steps in maximum, right? Because it will take n minus 1 steps. So 2 multiplied by 99, it will become 198, and 2 multiplied by 99 in maximum, it will also become 198, right? Now we have done the comparison in this step. Now I have to assign the greatest number. So here I can use 0 for best case and 99 for worst case. But in this executional part, I cannot use 0 in minimum, because in execution part we are always interested in the worst case. Got it? Now again, out max 1, 1 multiplied by 1, 1 multiplied by 1, right? So when I add up the value 198 plus 2, 200 plus 1, 201, 198 plus 198 plus 2 plus 2. So it will take 399 steps. So for analyzing the algorithm for finding the largest element of an array of size n equal to 100 will take 201 steps in minimum and 399 steps in maximum. Got it? Let's move on. Let's do the same problem for n. Here is the same algorithm. Here I have used a for loop from 2 to n. Same process. Now in execution part of comparison, look at closely. Now it will take n minus 1 steps in minimum and n minus 1 steps in maximum. Why? Because here we have to find the largest element of an array of size n. So how many steps it will take? In worst case, n minus 1, right? N minus 1, n minus 1. So according to rule, we have to multiply s into f to get the count. So when I multiply, it will become 2 multiply n minus 1, it will become 2 multiply n minus 1, and 2 multiply by n minus 1. So here 2 multiply by n minus 1. Got it? Again 2 multiply by 0, because in this step I have already found the maximum element. So in this step it is just the assignment process. So here I can use 0 for best case. But in this execution part, I cannot use 0. We have to consider it in a worst case, right? So now in this step, it will take 0 steps in minimum and again n minus 1 step in maximum, right? So 2 multiplied by 0, it will become 0. 2 multiplied by n minus 1, it will become 2 into n minus 1, right? Outmax, obviously it will take one step to print the value. 1 minus 1 will become 1, 1 minus 1 will become 1. So when I add up, 2 plus 2n minus 1 plus 1. Let me solve it for your understanding. 2 okay, 2 plus 2 n minus 1 n minus 1 plus 1, right? So when I solve it, it will become 2 plus 2 plus 2n plus 2 minus 2 plus 1, right? I can cancel 2 minus 2, okay? So finally it will become 2n plus 1, right? 2n plus 1. So here is the minimum value 2n plus 1. Got it? Now let me solve the maximum part, okay? 2 plus 2 n minus 1 plus 2 n minus 1 plus 1. Now 2n plus 2n, 4n plus 2 minus 2 minus 2 plus 1, right? I can cancel plus 2 and minus 2 and it will become 4n minus 2 plus 1, right? After cancelling this, it will become 4n minus 2 plus 1, okay? Now 4n minus 1, right? So after adding the following step, it will become 4n minus 1, right? I hope you have understood. So here is the steps. Let me revise it for you people. For finding the largest element of an array will take 21 steps in minimum and 39 steps in minimum for array of size n equal to 10. Got it? Now, for n equal to 100, it will take 201 steps in minimum and 399 steps in maximum, right? For n, it will take 2n plus 1 steps in minimum and 4n minus 1 steps in maximum. So if I write the analysis table at the end, here analysis table of n equal to 10, comma n equal to 100, comma n. the analysis table, number of steps, minimum runtime and maximum runtime. Minimum steps. Now the runtime complexity of an array of size n equal to 10 will take 21 steps in minimum and 39 steps in maximum. Runtime complexity of an array of size n equal to 100 will take 201 steps in minimum and 399 steps in maximum. Runtime complexity of an array of n will take 2n plus 1 steps in minimum and 4n minus 1 steps in maximum. ARTC, A represents for runtime complexity. Okay, I can add C here for your convenience. Runtime complexity, asymptotic runtime complexity excuse me, for an asymptotic runtime complexity would be omega n in minimum and O n in maximum, right? So here is the analysis table of all three algorithms. Now move on to second example. Design an algorithm to find the largest or smallest element of an array. Design an algorithm to find the largest or smallest element of an array of size n equal to 10, n equal to 100, comma n. Right? The same problem with a slight change. In this, we have to design an algorithm for largest and smallest both element, right? So here is the problem and here is the solution. In this, I have designed an algorithm, one variable for max, second variable for min, right? Loop will run from 2 to 9 for n equal to 10. If a into I is greater than max, then a into I max, and if first condition and the second condition for minimum, right? The rest would remain same. Now, the noticeable thing is when I analyze the complexity of algorithm, now it never happens both condition should be executed at once. Whether the algorithm will print the maximum value or the minimum value, right? It never happens a student can have A plus grade and A grade and B grade and C grade and D grade, etc., etc. It never happens. A student can only have A plus grade or A grade or B grade at a time. Student can never have all the grades at a time, which means that only one condition would be executed, only one condition will become true at a time. So while analyzing the complexity of algorithm, we will either take the steps of maximum or the minimum, right? But we have to write the logic of both the algorithms in algorithm. But while analyzing the algorithm, I will count the steps of maximum, which I have turned into red, or the minimum. Okay? So again, it will have the same steps what we have just witnessed, right? The same thing for n equal to 100, 201, 39, we have already analyzed it before. The same thing for n, 2n plus 1, and 2n plus 1, 4n minus 1, right? The rest would remain same. Move on. So here is the analysis table. Runtime complexity of an array of size n equal to 10, runtime complexity of an array of size n equal to 100, runtime complexity of an array of size n, asymptotic runtime complexity would be omega n or wn in best case, and in worst case it will on. It will be on, right? So it was the repetition of problem number 1 with the slight change. Now move on to third problem. Here we have to design an algorithm to find a Fibonacci series up to n equal to 10. Fibonacci series of n equal to 10. Now, I hope you people know what is Fibonacci series. You must have studied this in data structure. So what is Fibonacci series? Fibonacci series is the series which actually add the number of a number would be 1, 2, next would be addition of 2 and 1, next would be 3 plus 2, 5, next would be 5 plus 3, 8, next would be 8 plus 5 would be 13, next would be 13 plus 8 is 21, b is equal to 1, sum. Let me insert a table so I can explain you in a better way. Right? A, B, sum. So in this step, A is the 0, B is 1, and sum is 0, right? Now if I insert B in A, so it will become 1, and sum in B so 0 plus 1, for example, sum is equal to B is equal to A and sum is equal to B. You can see that in working steps. A is equal to 0, B is equal to 1, 0 plus 1, sum is the 1. Now I have assigned B in A, so A will become 1. I have assigned sum in B, B will become 1. So 1 plus 1 will become 1 plus 1 is 2, right? So again I have assigned B in A, so A is 1. I have assigned sum in B, so B will become 2, 2 plus 1, 3, right? B in A, it will become 2, sum in B, it will become 3, 3 plus 2, 5. B in A will become 3, sum in B, it will become 5, 3 plus 5 is 8. Same process, 5, 8, 13. Same process, B in A will become 8, sum in B will become 13, 21. B in A, it will become 13, sum in B, it will become 21, so it will become 34, right? B in A, it will become 21, sum in B, it will become 34, so 34 plus 21, it will become 55, I guess. Yes, 55, right? So B in A 34, sum in B 55, so it will become 65, 75, 85 plus 4, it will become 89, I guess, right? So here is the working steps. Now move on to analysis table. It will take one step, it's an initialization process. It will also take one step, minimum and maximum both 1 1. It will also take one step, right? Now for is not the executional part, so it won't take any computational steps. Sum is the execution part. So here is the two identifier, B1A second and sum is the third. So here it will take 3 steps and it will take 10 steps in minimum and 10 steps in maximum. So 10 multiplied by 3, 30, right? So here B will be assigned in A. Two variables are used. This steps will execute it 10 times in minimum and 10 times in maximum. 2 multiplied by 10, 20. 2 multiplied by 10, 20. Again sum in B. So sum is the identifier number 1, B is the identifier number 2. 2 steps. It will be executed 10 steps in minimum and 10 steps in maximum. 2 multiplied by 10, 20 and 2 multiplied by 10. Got it? Now Fibonacci series, because it's in the for loop, so it will take 10 steps. Minimum 1, maximum 1, 10 multiplied by 1, 10, 10 multiplied by 1, 10. So when I add up 1 plus 1, 3, 1 plus 1 plus 1, 3, plus 30, 33, plus 20, 53, plus 20, 73, plus 10, 83. It will take 83 steps in minimum and 83 steps in maximum. So here is the simple analysis of Fibonacci series, right? Here is the next problem. Now students, we have to read the following algorithm or pseudo code. The algorithm name is algo just do it, right? argument we are passing x and n, right? K is the 0, it's an initialization process. For I is 1 to n, do k plus x into I. X into I means the array of x, and I is the variable in which I will traverse the value of x. So I is a loop. I hope people must have studied in data structure how to traverse the array. We have to use the variable of a loop in the subscript, right? X into I means we have to add the value of k in every value of the array x, and then we have to assign that value in k. After assigning, I will divide the value of k with I, and then I will assign the result of that division in array A. And for I, return array and algo just do it. Now, what is the motive of this algorithm? Using SFC table, determine the counts of the total number of primitive steps performed during execution of algorithm in best case and worst case, and then determine how many primitive steps would be performed if the value of n is 10. And what will be returned by the algorithm if the array x has the elements 5, 7, 3, 5, 5, 5, 12, 6, 6 and 16. Also show the working steps, right? Now first of all, we have to design analysis table. Here, analysis table. In the initialization step, it will take one step, one in minimum, one in maximum, and count will be 1 multiplied by 1 in minimum and 1 multiplied by 1 in maximum. Now here, now first step, second step, and the third step, it will take 3 steps. So it will take 10 in minimum because we always interested in the worst case, 10 in maximum, we always interested in the worst case in both minimum and maximum, right? 30 and 30. Now k, here is step number 1, step number 2, step number 3. I will use k into I as a variable, one identifier. So 1, 2, 3, 3 steps, 3 multiplied by 10, 3 multiplied by 10, 10 multiplied by, because in this step I'm not gonna compare, I'm not gonna find the largest or smallest, I'm just printing the value. So it will take 10 in minimum and 10 in maximum. Remember, every algorithm is a different, so you cannot apply the logic of previous algorithm in next algorithm. So every algorithm is different in nature, so every algorithm has its own logic, okay? And for I, and return array, because here is an array of 10, so it will take 10 steps. A is the array, here you can see that, return array which is given in the problem, right? So one, it will print one element in minimum and one element in maximum, 10 multiplied by 1, 10, 10. Now when I count that, 1 plus 30, 31 plus 30, 41 plus 10, 71. 1 plus 30, 31 plus 30, 61 plus 10, 7. Right? So it's a analysis of that table. So here is the working steps. As you can see that in first column I have written the value of x which was given in the question. I is the value of loop, and k is the value of this variable, right? At starting, k is 0 plus x into I, right? So 5 is the first value of x plus 0. It will become 5. It will be like 2, 0, 5. At starting, k is 0. K to k x I, right? So next time k will become 5 and the next value of 7 would be, it will be like 5 to 5 and the next value of x would be 7. So 5 plus 7 is 12, right? Right? 5 plus 7 is the 12. Now 12 plus 3 would be 15. 15 plus 5 would be 20. 20 plus 5 would be 25. 25 plus 5 would be 30. So here is the working step. What about this one? So k divided by I. 5 divided by 1 is 5. 12 divided by 2 is 6. 15 divided by 3 is 5. 20 divided by 4 is 5. 25 divided by 5 is 5, and so on. So here is the working steps. I have drawn a table of working steps for your convenience. Okay, let's move on. Problem number 5. Design an algorithm to find the table of a number up to n equal to 10 and analyze it through SFC table. Here I have to design an algorithm which will print a multiple table up to n equal to 10 numbers, right? So here start algorithm table up to 10. I initialize I with 1, I initialize k with 1, and then table is the resultant identifier table with 0, right? For I 1 to 10, for j 1 to 10, and tab is I multiplied by j, right? Out tab and for and algorithm. Here is the algorithm. It will take 1 steps in minimum, 1 step in maximum. It will also take 1 step in minimum, 1 step in maximum. It will take 1 step in minimum and 1 step in maximum. Now loops are not the executional part, so I will calculate the steps of this. J, I and tab, 3 identifier is used, so I will write 3 over here. And I multiplied by j means 10 multiplied by 10, it will take 100 steps in minimum and 100 steps in maximum. 100 multiplied by 3 according to rule, minimum 300 count and maximum 300 count. Now tab is inside the for loop, so it will also take 100 steps, 1 at a time in minimum and 1 at a time in maximum. After multiplying, 100 multiplied by 1, 100 multiplied by 1, 1. So when I add up 300 plus 100, 400, 1, 2, 3, 403 in maximum and 403 in minimum and 403 in maximum, right? Here is the working steps, how computations done in memory. I is 1. When I reaches loop j, the value of I is 1 and the value of j will starts with 1. So I multiply by j, I multiply by j means the value of I is 1, the value of j is 1, 1 multiplied by 1, 1. The value of I is 1, the value of j is 2, 1 multiplied by 2, 2. The value of I is 1, the value of j is 3, 3 multiplied by 1, 3. Right? So the value of I, which is 1, will go through all the values of j. When 1 will go through all the values of j, raw 1 will be printed. Then the value of I will become 2. And then again 2 will go through all the values of j. The value of I is 2 and the value of j is 1. 2 multiplied by 1, 2. The value of I is 2, the value of j is 2. 2 multiplied by 2, 4 here, right? The value of I is 2 and the value of j is 3. So 2 multiplied by 3, 6. The value of I is 2, the value of j is 4. 4 multiplied by 2, 8. So when the value of I, which is 2, will go through all the values of j, the second row will be completed and so on. When all the values of I and all the values of j will be executed, the loop will reach to this point. So here are the working steps of the above algorithm. At the end of this algorithm, I conclude today's lecture. I hope you people have understood the lecture. If you like the lecture, don't forget to like, subscribe and share with your friends and colleagues.